Hello and welcome to this session. So in this session we're going to be talking about network security, and this is what we basically want to achieve in terms of security when it comes to networks and systems. And thank you for joining me in this session. If you're into this kind of content, remember to hit the like button, comment down below, and subscribe to my channel so that you're updated each time I upload a new video. So welcome, and let's get into network security. Now this one is going to be a very kind of long session, so try to understand. So let us first look at network security goals. We want to achieve three things, and they are defined by the seared triangle, or what we call a SIA. And C stands for confidentiality, I stands for integrity, and A stands for availability. When you're talking about confidentiality, we want to hide, or we don't want other people to know what our networks are transporting, or what is passing through our networks. We don't want packet sniffing. We don't want any type of manipulation of flow of traffic when it comes to our networks. When it comes to integrity, we want to make sure that what we send is what is received. Okay, from point A to point B, what is sent is what is going to be received on the other end. And when you talk about availability, is how the uptime of our networks, how long are we going to be down. So that is what we mean by availability. Now let's talk about confidentiality in detail. And confidentiality is achieved by deploying security appliances. So we talk about firewalls, and we could have several of them. One of them is host based, which is on the specific machine. We have packet filtering firewalls. These are access control lists. We have what we call as stateful firewalls, and next generation firewalls, which look at more than what is passing through. They look into detail of that specific packet. We could deploy what we call as a demilitarized zone, and this is what we define as the space in between our network and the external network. Take for example, in countries we have as what we call as the no man's land, and this also applies in networks where we deploy a demilitarized zone, such that when a person who is not authorized in our network tries to access our network, they're going to first get into the DMZ, that is the demilitarized zone. We could also achieve confidentiality by configuring intrusion detection systems, and these are basically systems that you place inside your network to get copies of your traffic, and they're able to detect whether the packets that you are receiving, or the traffic that you are receiving in your network, whether it's malicious or not. When you talk about an intrusion prevention system, which can also be applied as a security appliance, this sits in between our network and the external network. It could be at the firewall, it could be between the firewall and your router, your main router, and this basically prevents malicious traffic from getting into your network. It does not only get copies, it prevents the intrusion detection system just gives you notifications of whatever malicious traffic you are receiving. Now, another way we could achieve confidentiality is configuring access control lists. Remember, we talked about packet filtering firewalls. and these are basically access control lists, and this is where we permit or deny traffic inside our network. It can be inbound or outbound, and the access control lists are processed from top down. So if you configure an access control list in a router or a firewall, they are going to be processed top down. Whatever you put in first is going to be processed way later. And when we are talking about access control list, we have several of them. There's what we call as the numbered ACLs. We have what we call as the named ACLs, meaning that you give either assigning a number to the access control list rule, or you are assigning a name to the access control list rule. We have what we call as the standard access control list, and the list goes on according to different network vendors. Now, in an access control list, you need to make sure that you take note of the implicit deny rule, and this denies traffic from any network by default, not stated in the access control list. So whenever you are you configure an access control list, remember there is an implicit deny statement that will deny traffic from any other network not specified in the access control list. Now, also to achieve confidentiality, we could use encryption, and this is where we encrypt what we are transmitting from one network to another, and this is where we use private and public keys. This is what we call asymmetric encryption, and this means that using a shared key, a shared public key, and this means that you generate a key, you share it with your other network administrators or CISO or colleagues, and they could use that key to access that network, okay, or the traffic that is flowing into that network. Now, for asymmetric encryption, this means that you have both a public key and a private key, and the private key can be changed, okay. So if a person got a hold of your private key, and you have not given permission for that private key to be used, it will be basically useless. So that is what I mean by asymmetric and symmetric encryption. For symmetric encryption, we have DES and AES as the encryption algorithms available, and we also have a RSA for asymmetric encryption. Now, let's talk about integrity. This way we make sure that whatever is sent is exactly what is received on the other end, and to achieve this we use hashing algorithms. And what I mean by hashing algorithms is that you're going to assign a number, or let's say for example, when you're keying in or stocking a market, you need to assign numbers to those specific products, so that you're able to know that this product with this certain number or this certain code was taken. You're able to verify that this is the actual item that was taken, and you can trace it from one side to the other, okay. And there are different algorithms that help us to do this, and we have what we call as the SHA-1 algorithm. We have MD5 and HMAC. Now let's talk about availability, and this is measured by the number of times or the number of minutes a network is down per year. We have what we call as the 5 nines, and this means that you are 5 minutes down. We have what we call as the 6 nines, and this means that you're 30 seconds down per year, or your network is down 30 seconds down per year. Let us look at some of the common network attacks that you could launch, or what you could come across. We have what we call as the denial of service attacks. These are called DOS attacks, and this is whereby one pings the broadcast address of a network. Remember, broadcast address sends traffic to all other machines in the network. So when you send a request to the broadcast address of a network, all other, when it replies to all other hosts that are in that specific network. So when you ping it, you're basically going to when you ping it continuously, you're going to basically create a traffic that is going to deny service to other PCs. We have also what you call as the distributed denial of service attacks, and this basically means that you are pinging the broadcast address of a network using multiple zombie computers. And what I mean by zombie is just that you have set them up to just perform one task continuously. Okay, that is pinging the broadcast address of a network. You have what we call as on-path attacks, also known as the man-in-the-middle attacks, and this is whereby an attacker somehow injects themselves inside a communication flow between systems, or between networks. This enables them to intercept, that is received data that they are not supposed to receive, or they're able to manipulate the flow of that traffic, or network traffic. We have some of the attacks. One of them is MAC address flooding, and this is whereby an attacker floods a switch with the fake MAC addresses, filling up the MAC address table of a switch. This makes the switch to start learning again the hosts in a network through address resolution. And in here, when the switch is learning, the attacker can attach themselves with as many machines as they want to that specific switch. An example of a tool that is used is a Markov, and this is a tool used to launch this kind of attacks. The mitigation for MAC address flooding is configuring port security, and this is whereby you specify the MAC addresses that are supposed to be attached to that specific switch. You specify the machines that you want to specifically use those ports, such that if another person comes and attaches themselves in that specific switch, the MAC address will read a negative, and they are not going to be able to use or to be in that network. We have what you call as the app poisoning, and this is whereby you send unsolicited app replies, and these are sent to the victim, claiming to be the MAC address of the victim's default gateway. This is where a person lies to you, and they tell you to change the connection of your default gateway. They basically fool the victim to change the default gateway to the attacker's default gateway. And what you can basically do to mitigate this is configuring a dynamic app inspection, and this is whereby you're specifying the MAC addresses that are supposed to be in this or are supposed to be resolved by that specific switch during the MAC address learning by the switch. Now we have another attack that is the rogue DHCP, and this whereby the attacker the attacker attaches a DHCP server. A DHCP server is that specific server that is assigned the role of assigning IP addresses to hosts joining a network. So the attacker will attach a DHCP server, and the DHCP server will lie to the victims that it is the legit DHCP server. So instead of being assigned IP addresses that are in the network, they're going to be assigned other IP addresses that are in the attacker's network. Thereby the attacker can basically manipulate and get this information that is not supposed to be accessing. A tool that could be used to launch this attack is their senior tool. It's available on Kali Linux, so you can go and try that out. Okay. Mitigation for rogue DHCP is configuring DHCP snooping, and this is whereby you specifically assign a DHCP server to a network, thereby making sure that the host in a network are getting legitimate IP addresses. Let us look at another type of attack, that is the villain hopping attack. And we have two attacks in this specific attacks. We have what we call as switch spoofing, and this is whereby an attacker gets to pretend to be an Ethernet switch and set up a trunk interface that is carrying traffic for all VLANs. So they're basically going to get into your switch, attach themselves, then they are going to configure a trunk interface between the victim switch and your switch, and they can access traffic from all VLANs. And VLANs is the different departments that you have in your network. We have what we call as a double tagging attack. This is whereby an attacker adds two VLAN tags to a VLAN frame, such that a frame, when sent to a switch, it will be sent to two different VLANs, the attacker's VLAN and the legitimate VLAN. And this is done by configuring an outer trunk that is tagged as the trunk VLAN, and the inner trunk is targeted to the target VLAN. We have what we call as social engineering attacks, and this is basically whereby you have to engage the person. We always say that the weakest link of a network is always the human being. So this is whereby you can lie to a human being, and they are able to give you access to the specific network. And there are several attacks that you could launch. You have what we call as phishing attacks. This is whereby you send fake emails, fake messages, and you send a link to this specific person, and when they click that link, you can either get a remote access, or you can be in a position to get into their networks or their specific devices. We have what we call as tailgating, and this whereby you can rush behind a person when getting into a physical building that you know that you can attack. You go behind them as they enter a door, and you tell them, hey, hold for me that door, and they hold for you, and then you just enter, and you have basically gained access or physical access to that specific building. We have what we call as shoulder surfing. This happens mostly at ATMs, or when you're surfing through your phone in a public area. Someone comes at the back and tries to look at what is happening on your screen. Okay, so that is what we call as a shoulder surfing. We have what we call as a malware, and this could be sent through phishing links. And malware is basically a malicious software. This is software that we have what you call as a malware, and this is basically malicious software, or a software that is not supposed to run on your system or on your network. This could be either in form of apps or just basic applications that are triggered to open in your system that are not supposed to be there. To get more information on this, you could look at the Mataya framework. And I've said the malware is a malicious software. This could be spread through phishing links, and you basically call someone, or you convince someone to click a link that they are not supposed to, and that specific software runs. We have what we call as a DNS poisoning, and this is basically where you lie to the victim when they are trying to resolve a certain address or a certain name. Let's take for example the legitimate IP address for Google. This is just an example. The legitimate IP address for Google, let's say it's 192.168.1.2, but when someone types in the web browser google.com, the IP address that is resolved is of another server with another different IP address. This is what we call as a DNS poisoning. We have what we call as a ransomware, and this is also spread through phishing links, and this is whereby someone sends you a link, and this link has some kind of software running, which is a virus, and it encrypts all your data, and they basically ask for money in order to give you the encryption keys or the decryption keys for that specific attack or a ransomware attack, and this basically extortion. Okay, let's talk about spoofing. And spoofing is whereby this is also lying to either be the legitimate Ethernet switch, the legitimate default gateway, that is the way outside to the outside internet, and spoofing is just basically lying to the victim or giving fake information to the victim when they are trying to access the internet. We have what we call as de-authentication attacks. These are basically wireless attacks, and this is whereby someone places a wireless a rogue wireless access point, and they basically send a pop-up message telling you that you have connected to the wrong network. To sign in, kindly connect to this network. So you sign in, and you are in the wrong access point that manipulates the data that is supposed to be in this specific network. We have what we call as a brute force attacks, and this is where basically you try to log in to a system by breaking passwords. You try to guess all these usernames and passwords to a specific system, and you log in as an illegitimate user, or a person that is not supposed to access this specific account or administrative levels. And brute force attacks could be run through some tools in Kali Linux, so kindly stay tuned for some of these kind of attacks. Let us talk about how we can now defend ourselves from all these attacks that we have talked about. And this is we have several ways. One of them is signature database management, and this is where we keep attacked signatures, or whenever we were attacked in a system, assume we were compromised in a system, we basically keep the network traffic, or how was the traffic at that specific time when that attack was happening. And this could be done by use of devices such as the intrusion detection system and the intrusion prevention system or sensors. We have what we call as a device hardening, and this is where we basically apply a collection of best practices or procedures to make sure that network devices are secure enough. And this can be done by disabling unnecessary services, ensuring there is authentication, and maintaining the device, making sure that the software is up to date, and such kind of procedures. Another way that we could defend ourselves is by changing the native VLAN of our switch. And the native VLAN, as we know, is supposed to transport untagged traffic. So you change the native VLAN, which could be common to devices, say from one network vendor. So you can change the native VLAN to make sure that one does not just guess a VLAN and they are able to access the information from that specific VLAN. We have what we call as defining a privileged user accounts, and this will basically assign different administrative levels to user accounts in a system or in a network. And this whereby you define this is the administrator, these are the types of roles that they are supposed to run, and you clearly define those privileges that are given to that specific user. We have what we call as a file integrity monitoring, and this is whereby we can use a service that can detect when changes are made to define the files. Okay, you basically apply a system or a service in your system that can detect changes when it comes to certain files. We have what we call as a role separation, and this basically means that you assign different sets of permissions to different users, and this could be weighted by the point of defining privileged user accounts. Okay, where you have different privilege levels. You have defined that certain users can do certain types of jobs, while other types of users can just gain certain access to systems or networks. We have what we call as a honeypot deployment. This is just by configuring a host that does not contain any sensitive information and make it intentionally vulnerable, so that when somebody tries to access your network, they just get into these honeypots, and you basically waste their time. This you can also deploy an IPS to just tell you that there has been malicious traffic that has arrived in our network, and it is in the honeypot. So you just look at them and you laugh at them, and you feel good about your system, knowing that you are secure. We have what we call as a network segmentation, and this way you basically divide your network into different segments or VLANs, and the demilitarized zones. We talked about demilitarized zones earlier in the video, so go look at that. We have a defense in depth, and this is whereby you apply multiple layers of security. Whereby you start by physical security. When it comes to networks, make sure that you start from your gate. Make sure there is security. When you're coming into the building, have security in there. When they're going into these specific rooms, have security. When they get into the devices, have security such that they cannot just access administrative levels in these devices without authentication. And this basically helps you to reduce the types of attacks that you can basically have in your system. We have what we call as a zero trust. and this refers to an approach to a network security where no user is given a default set of permissions, but instead requires them to authenticate for each zero trust means that you are giving least privilege access to users and the types of jobs that they can do, and for each job they have to do, they have to authenticate. That is what we mean by zero trust. And just to give a good definition, we say that zero trust refers to an approach that to a network security where no user is given a default set of permissions, but instead requires them to authenticate in order to be assigned an appropriate set of permissions. And we talked about least privilege, and this way you give your users least permissions or minimum permissions in that system, but still allow them to do their work. Now let us look at authentication, and we are going to look at two types of authentication. We have what we call as user authentication and multi-factor authentication. So authentication means it just poses the question, who are you? Authorization poses the question, what are you allowed to do? Accounting, what did you actually do? That is the triple A. Authentication, authorization, and accounting. Who are you? What are you allowed to do? And what did you actually do when you were allowed into the system? When you're talking about multi-factor authentication, we want to know what a user knows, what a user has, what a user is, where a user is, and what a user does. And for these two types of authentication, we have protocols that enable this, and we are going to look at first the user authentication standards or protocols, and we have TACAs, which is Cisco proprietary, and this could change according to vendors. For example, for Huawei, you will have Huawei TACAs, but Radius is a standard, an industry standard. Yes, an industry standard. So Cisco TACAs is a Cisco proprietary. It is TCP based. It separates the AAA functions, that is the authentication, authorization, and accounting. We have two-way response. That means that you're involving both the user and the server. They have to communicate, and it TACAs encrypts the entire packet. When it comes to Radius, that is the industry standard for user authentication. It is this UDP based. It combines the AAA functions. That means that you just provide one type of information, and you're allowed to do all other the three. It's a one-way challenge, meaning that it does not involve both the user and the server. It's only one way, whereby the user has to authenticate, and that's it. That basically is not right, and it only encrypts passwords. Radius only encrypts passwords, and that is not enough to encrypt or to ensure confidentiality of our network traffic. So those are the two user authentication standards. We have TACAs and Radius, and I have said that Radius is industry standard, while TACAs could change according to the network vendor. Now let us look at multi-factor authentication security standards, and we have three of them. We have network access control, we have what we call as MAC filtering, and we have what we call as the captive portal. Okay, and in multi-factor authentication, we have what we call as the single sign-on server, that is Cabros, and it uses the lightweight directory access protocol to grant access to users or clients in a system, and these are separate system from the file server itself. And some of these sign-on servers use a public key certificates. So in the Capdros, which is the single sign-on server, we have the client as shown on the screen, and we have the key distribution center and the file server. So the client will first be required to authenticate to the key distribution center, and the key distribution center will grant them a ticket, and later the client is supposed to use this specific ticket to gain access to the file server, and this is what we call as the Capdros or the single sign-on server. Now that is whatever we have looked at is for physical networks. Let us look at wireless networks. And in wireless security goals, we basically have two of them. When a person or a client is getting to our access point, they have to authenticate, and encryption has to apply so that you cannot basically access whatever one person is doing from the access point. So authentication provides users this is where users provide the credentials such as usernames and passwords to gain access to the network, and the encryption is making sure that the packets are scrambled up such that if they were intercepted by an attacker, the attacker would not make sense of them. And I talked about wireless security in a separate video, since security is quite a large topic. So if you haven't watched the wireless security video, kindly go and watch it. So that's it when it comes to network security. Thank you for joining me in this one. It was quite a long one. I would want to assure you that a lot more is coming. Okay, I have a lot more of content coming on the way. It is just that it takes a lot of time sometimes to make sure that the content that I'm giving to you is accurate, and I'm in the process of developing a few videos, so make sure that you go through the basics because when we start doing advanced stuff, you'll feel comfortable, you'll not feel left behind. So thank you for joining me, and see you in the next one. Peace.